time for the boring stuff, the theory. We're going to take the cover off this magical box called a computer, think a bit about binary, why computers need binary, and inputs and outputs, and hopefully you take away from this the rough idea of how computers really work. Let's get into it. So, you've got a box, okay? This box is a computer. And what this computer does is, it takes stuff in, processes and messes about with them a bit, and puts stuff out. In fact, that's the definition of a computer. Can we just look at this definition of a computer? Look at this first sentence. An electronic device that stores and or manipulates information. That's it. In fact, by that definition, a light bulb technically counts as a computer. Think about it. It takes stuff in, it manipulates it, and it pushes it out. The reason it manipulates it is because if the switch is off, nothing comes out. However, if the switch is on, the signal does come out, so clearly it does manipulate the power coming in. Now, when I say the stuff that goes in, I don't mean it physically. I just mean when data comes in from somewhere else outside the computer, like a wire plugged in or Wi-Fi. Alright, well, let's start naming these things because the stuff that goes in isn't very technical. Well, the stuff that goes in is called an input. They are things that are literally put into the computer. Then come the outputs. These are the things that the computer puts out. Now, what do we call this bit in the middle here? The bit that manipulates the inputs to make outputs. We'll just call this the process. In fact, by definition, a process is a series of actions to get something, and this is exactly what the computer is doing. It's doing a bunch of things to the input to get an output. Let's just think about this a bit. Is a keyboard an input device, a device that inputs stuff, or an output device? Let me just give you 5 seconds here. And it is an input. It puts the keys that you press into the computer using a wire. Okay, what about a mouse? Is that an input or output? I'll give you 2 seconds here. It's an input as well. It tells the computer when the mouse has moved. Now, this model, input, process, output, doesn't include the fact that computers store data inside them, which you may have seen in that definition of computer. But actually, you could count this as still part of the process, because although the computer is storing that data, it still has to process and output it for you to see it. Okay, so we've gone over the general idea of what goes on outside this mysterious black box, and you might have already known quite a bit of that, but I want to keep everything simple, because the last thing I want to do is just leave you behind and make you start thinking, what the hell is this guy talking about? Right, well, I think it's time to take the cover off this box and get a brief idea of how it processes. Alright, so inside there are millions and millions of tiny little wires that go all around the different little components, which I'll get into in the next video. And of course, nobody can remember all of these wires. No one in the world knows how every little tiny bit of a computer works. People who make the components of a computer are in their thousands and only specialise in certain areas, so don't worry about all that. Well, we have these wires now, and this is where it gets important. Every single one of these, a million tiny little wires, are either on or off. Just like your light switch, it's either on or it's off. This is actually what a digital signal is. Everywhere you hear the word digital, it technically refers to a bunch of on or off cables. It's one of the two, on or off. And this is where binary slowly starts to come in. This is called a bit, on or off. That is a bit, a single bit of a signal. Now of course, computers need to transfer all sorts of data around them. So what they do is they put a big batch of these bits together, and this batch of bits represents one thing. Now I want you to think about this for a second. If you wanted to send a number between 0 and 255 from point A to point B in the computer, how would you do that with just cables that are on or off? I'll just give you a few seconds to think about that. What you might say is, oh, just have 255 little cables. If the first one is on, that's a 1. If the second one is on, that's a 2. If the third one is on, that's a 3, and so on. Now, that works, but that's such a massive waste of cable. What you're forgetting is that you can have combinations of on or off as well. Like, if this cable is on and this cable is on, that's 12. So, if you use different combinations of on or off to represent different numbers, you need much less wires than you would have before. And look at how big of a difference this makes. You can have 256 different combinations with just 8 wires. Yeah, all you need are 8 bits of data and you can make that number. Now obviously, computers handle much bigger numbers than 256. How do they do that? Well, they have a bunch more cables batched together. 16 bits gives you 65,536 different combinations. Yeah, now can you see why computers use binary? And look at this. 32 of these bits gives you a massive 4,294,967,296 different combinations. Yeah. Now, of course, you do not need to remember those numbers. They're practically useless, really. I just wanted to get across why computers use binary and how it takes advantage of the fact that you can have different combinations of on or off cables. So, let's name some of these. When you have a big group of bits or cables put together to transfer only one thing, that's called a bus. And I know it sounds weird, but I guess you just sort of think of it as transporting the data around. So that's that. When you have 8 of these bits or cables, that's called a byte, spelt B-Y-T-N-D. Now, you might have heard the terms 32-bit computer and 64-bit computer, and based on what I just told you, you might be able to figure out roughly what it means. A 32-bit computer is a computer where the majority of the buttons inside it have 32 bits. Now, this is alright, and was fine a while ago when computers weren't quite as advanced as they are now, but as you know, 32-bit still has a limit. Now, that's not saying 32-bit computers can't transfer around 64-bit numbers. They can. They can literally split the number in half into 2 32-bit sections, then put them down 2 different buses, and then put them back together at the end. But this can be slow. It takes extra processing to split up the number and stick it back together. And when you're running some really advanced games that do thousands and thousands of really big calculations, that processing adds up. Which is why we've moved over to 64-bit computers now, where the majority of the buses are at 64 bits, which is literally a ridiculously sized number that I've just slapped on the screen. A number probably big enough to reference every single YouTube video and tweet together. I'm not even going to bother saying the number. Alright, so now let me just go over everything I've just mentioned, because obviously I want you to remember this stuff, and this is the general idea of how computers work, and we're going to be referencing quite a bit of this stuff when we're programming. So I'm going to quickly recap on everything we just learned so that we all understand this. A computer is literally a device that takes in inputs, processes a bit, and then chucks out outputs. If we look inside that computer, we'll find a bunch of components connected and made of millions and millions of little wires. Each of these little wires are either on or off. It's simple as that. They are simply either on or off. Now, of course, we can't really do very much with just a 1 or a 0. So what we do is we group these bits together into a bus. And this bus can be a whole range of sizes, all the way from a byte to 64 bits, to maybe even higher for some seriously powerful supercomputers. These buses transfer information by using lots of different combinations, and the reason they do that is so that they don't need that many cables inside them. But how do we actually know what combination is what number? Well, we use binary, and binary is essentially the way we represent these numbers. For example, in binary, if all the cables are off, then that's a 0. If the first cable is on, that's a 1. But if the first and second cables are on, see what I said about using combinations, that's actually a free. Now, you don't need to worry yourself about what numbers are what binary. It's actually really simple, but we can do that later because I don't want to be throwing information at you really quickly. And that's all there is to remember for this video. There it all is on the screen right now. Now, if you really wanted to, and I know this probably looks hideous to most of you, but if you seriously wanted to, you could technically make this your background. It would remind you of all of this every time you see your desktop, so the option is there. And there you go. That's episode 1. Hopefully that was a pretty good explanation. It's difficult to explain this stuff, and in the next video, in a way, we're actually going to think about something kind of quite a bit simpler than this. And it's literally just the components that I kept mentioning inside a computer and what components do what. But until then, have a good time and try not to forget all this. So if you enjoyed this video and it was helpful, just go ahead and, well, you know, hit that like button, maybe subscribe. Come on, you know you want to. I'm aiming to upload each of these videos possibly every fortnight. After all, this is only a hobby and it's only a small portion of the time I actually feel like making videos as opposed to working on my own projects. So sorry about that. If the next video hasn't come out yet, well, it will say over there, won't it? Okay, bye.